Next experiment is of studying the characteristics of DC servo motor speed characteristics study unit. Here also, as we done with the AC servo motor, here also we are going to learn for servo motor when a supply is given in terms of a DC. Here the aim is going to be to study the DC servo motor speed characteristics and plot the graph. The front panel, this is the construction, the unit kit what we are going to be using. Here the servo motor is connected. For this a motor and about a sensor output the motor. This is the speed controlling. Here is the display units in terms of current and in terms of the speed. This is on off switch for servo motor. Here the power supply. It is consisting of the mains on and off switch to the unit with the built-in indicator, then LCD display, meter to display the speed in RPM, then ammeter, the meter to display in the load current in the amps, then servo motor, DC in terms of DC, supply on off switch to the servo motor, and a port it's connected potentiometer to vary the DC supply to the DC servo motor. Then VDC applied here is a 1.5 volts to 24 volts supplied terminals of DC, and the tacho generator output unit it's connected, and if used 2 amps of glass fuse for power supply production it is connected for the kit. This is what it's going to be. Then the unit mainly consists of DC servo motor whose characteristic is to be studied. A variable DC supply is provided to vary the speed of the DC motor. The tachometer is provided to read the motor speed in the RPM directly. A pulley is fitted to the shaft of the DC motor. Here in this construction, a shaft of the DC motor, servo motor, for mechanical loading of the arrangements. Here mechanical arrangement is done. A motor will be rotating. A pulley is going to be connected for here. Based on this, a mechanical rotation will be coming across. Then a belt and 2 spring balanced are fitted to the load motor in this construction. Then the theory for this is going to be, there are many types of DC motors used in the industry ways. DC motors that are used in the control systems are called as DC servo motors. In DC servo motors, the rotor inertia have been made a very small, inertia is very small, with the result that motor with a very high torque to the inertia ratio are going to be commercially available. Due to this, some DC motors with a relatively small power ratings are going to be used in the instruments, and computer related instruments are going to be used. DC series and shunt and permanent magnet DC servo motors with the medium and large power ratings are going to be used in the robot systems and CNC machines. And normally they are available with the built-in tacho generator for speed sensing, how much speed for the required robot or any of the machine is required, that is sensed by that machine in a closed loop control applications. Most important among the characteristics of DC servo motor is the maximum acceleration obtainable. This is the main advantage by using of the DC motors. Then for the given available torque, the rotor movement of inertia must be maximum, since the servo motor operates under continuously varying conditions. Acceleration and the acceleration of the rotor occurs from time to time. The servo motor must be able to absorb the mechanical energy as well as it should be generated. The performance of servo motor when used as a brake is satisfactory. Next, the speed variation and speed control is going to be a variable DC supply with the 1.5 to 24 volts approximately is going to be generated. This variable DC voltage is used to vary the speed of the DC motor. The servo motor is fitted with a photo reflective sensor to sense the speed of the DC motor. Here we are going to be using photo reflective sensors. The photo reflective sensor generates a pulse pulses whose frequency is proportional to the speed of the DC motor. That's what the advantage of this. In this unit, the frequency of the photoreflective sensor is taken as a reference for the speed sensing. This signal is fed to the signal conditioner and then to the microcontroller. Then microcontroller is programmed to display the speed in the RPM directly. Then torque measurement is going to be, in order to measure the torque produced by the DC servo motor, we have an arrangement to produce the variable load on the DC servo motor. The DC servo motor is fitted to the front panel and its shaft is extended outside the front panel, and a small aluminum brake drum is fitted. The construction, what it is shown, servo motor construction is away from this panel. We have to connect this arrangement to the main panel. Okay. Then a small aluminum brake drum is fitted to the shaft for the loading. A small leather belt and two spring balance are fitted. What we explained the previous, the same thing, to the belt on the sides and fitted to the MS channel. Then a wheel is fitted to the one side of the shaft for varying the speed. This is about the theory part and how the control panel is there and what is about the theory. Then about the procedure is keep the load at a no load condition. Then switch on the main supply to the unit. Then next step is switch on the servo motor in the on switch. Vary the speed of the potentiometer till the DC voltage reaches the 24 volts. Then note down the low load current and no load speed. Then adjust the load in steps till the load current reaches the 0.8 amps. You should not exceed more than this. At each load, note down the speed, current and spring balance readings. Then calculate the corresponding torque and plot the torque speed characteristics and repeat for this for 60%, 40% related voltage. This is the tabular column where you have to note the voltage, current, the speed, and how much the weight we are going to putting in terms of a gram, W1, W2. Then total W2, what is difference is going to be that you are getting a W. Then torque is going to be that is equals to W into R. This is what the nature of the graph with the speed with respect to the torque. Where this is for 24 volts rated voltage, which is going on downing for 60% and 40%. This is how nature of graph it will be getting when you take the readings for this.